Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Firdaus by Mohamad Suki, matrix number DE220088. In this video, I will present about introduction. A controller controls the behavior of system by comparing the actual output to the desired output and modifying the input as necessary. A controller can be either software or hardware. The two types of controller are open loop and closed loop based on whether or not they include feedback from the input to the output. Open loop system don't actively measure or correct the output, thus even while they are simple to create. They might not always be accurate or stable. On the other hand, because of their feedback mechanism, closed loop systems are thought to be more dependable despite being more advanced. In order to change the input and lower error, this system produces an error signal that shows the difference between desired and actual outputs. The PID proportional integral derivative controller, which has three parameter proportional, integral, and derivative, is one common kind of controller. The input is adjusted by the derivative parameter according to the rate of change of the error, the integral parameter according to the sum of the error, and the proportional parameter according to the current error. Several tuning technique and the Ziegler-Nicholas approach and simulating PID tuner are used to optimize the ID controller. While the Ziegler-Nicholas method, a classic tuning approach, determine ultimate gain and ultimate period from the system response to the step input or proportional control and the calculus PID parameter using empirical formula simulating PID tuner automatically modified PID parameter using a linear plans model. I think that's all from introduction. Thank you.
Assalamualaikum. My name is Mohamad and my visit number is DE220109. So I'm gonna show you our open loop system. So the open loop step response can also be generated directly within Simulink without extracting any models to the MATLAB workspace. In order to simulate the step response, the details of the simulation must first be zero. Double click the step block and set to the time 0. So inside our DC motor, this is the block diagram we create. So this has a resistance, inductance, inertia, and so on. And the final model should appear as shown in the following video. So this is the final model. So then run the simulation. Select run from the simulation menu. When the simulation is finished, double click on the scope and you should see the following output, which is this one. So this is our graph for the open loop system. Okay, for the next method is Nicholas method. First step, open MATLAB and then click the new last script button. And second step, just set the coding. This is our coding and set the variable k, l, and t. So based on the open loop graph result. And to get the k, l, and t value, use the Ziegler's method. So based on the Nicholas method, on the graph, this is we should pull this line until the top, the maximum value, which is 0.1. So this is our k. And after that, we pull the line 90 degree down all the way, and we should get the L and T, which is this is L. The L, our L, we get 0.08, and this is our T. And our T is 0.72. Okay, so after we get the K, L, and T value, we put in our coding for this K, L, and T. And this is the formula A, T, I, and T D. And put the formula here to get a PID value. And after that we can run the simulation and we will get this graph. And this is our step response new graph. And as you can see, this is our PID value, which is P is 108, I is 675, and D is 4.02. Okay, for the next method, which is PID tuner on the closed loop system, the first step is set the configure system and use the same block system like previous open system, but insert the sum junction and PID controller. And second step is set the closed loop connection. Connect to each block into the closed loop connection based on the diagram. And firstly, click and drag to connect the step block to the positive input of the sum block, and connect the output of the sum block to the DC motor block. Loop the output of the DC motor block back to the negative input of the sum block to create the feedback loop, and connect the output of the DC motor block also to the scope block to visualize the output. So after we settle the board diagram, we good to go to run the simulation. And to run the simulation, click the PID controller and select the tuning method, which is PID tuner, and then click apply. So before that, set the PI, and PID values. Okay, after we set the PI, and PID values, we can inject the graph. So this is the step plot for P, and this is the graph for PI, and this is the graph for the PID values.
Okay, next is result. I will present about result and discussion. For this result and discussion is about open loop system. So this is the plot diagram of open loop system, and this is the output graph of open loop system. Okay, a controller system that modify its output without using feedback is called an open loop system. It consists of a actuator, a controller, and sequentially connect process. The first block of on the left in the diagram, which is empty, represent the system in input. A voltage speed block, which is DC motor, was created in the middle block. The DC block was represent the system dynamic behavior. This block represent a simplified model of a DC motor. The DC motor block is used to simulate the dynamic behavior of a DC motor in a simulated model. It includes parameters such as armature, resistance, inductance, back EMF constant, moment of inertia, and damping factor. This parameter characterize the electrical and mechanical properties of the DC motor. The system output or reaction is represented by the last empty block on the right, which is called scope. For the graph, you can see it's a curved line result. Okay, that's all for open loop system. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad, Aiman Ahmad Khairi. My metric number is DE220154. So I will explain about the closed loop system by using Ziegler-Nichols method. So first, we using the Ziegler method, and for the open loop, so we use the closed loop, and so to simple technique to adjust the PID controller, Ziegler method sometimes referred to the Ziegler-Nichols tuning method. It's intends define the ultimate gain, ultimate period of the system, and using this value to set the P, I, and D of the PID controller, which is proportional, integral, and derivative. So uh, from the open loop graph, we can identify the K, L, T. So what is just the KLT? K is the input, L is the rise time, and uh, T for the peak time. So uh, we we using this formula to find the PID using the KLT value. So from the graph, we get the KLT value, and so that we can calculate the value PID from the table to get the answer. So after calculate the formula, the value, and the summarize PID is for the P value is 108. For integral is 675. For the derivative is 4.32. So after we get the value of P, I, and D, we can insert the value from to the coding, and we get the graph for the Ziegler using the Ziegler-Nichols method, and the output graph is this. So we can say that the system is stabilized because of the percentage of that is less than 5%. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Rafiqi bin Shamduddin. My matrix number is DE220185. And my part presentation is about PID tuner as non-PID controller, as you know. This is our MATLAB simulating block diagram for PID controller. And this is a step response for PID controller simulating. We do in the block parameters PID controller, this block. And in the controller, we set PID. Form is parallel, the domain is continuous time, and settle time is -1. So for the main controller parameters, for the source we set as internal, proportional 108, integral is 675, and derivative 4.22, filter coefficient 100. And this is our result, graph result for the step plot reference tracking. Amplitude is time seconds, PID controller. And controller parameters, we got result tuned every component. every main, which is proportional, we get this value, integral negative 49 something, and the derivative we got value negative 1.6. Total coefficient we got 405.4947. That's all for me. Thank you.